This is Professor Antonio S. Marahas, and this is Advanced Digital Technique. So, we go now to Minterms and Maxterms. We are still under the K-map discussion. So, Minterm is actually a representation of sum of product expression. Okay? And this Minterm is actually represented by the symbol summation of small letter m. Okay? Again, we have here a truth table which is based on a particular problem. The output here is based on the condition of a problem. Okay? So, how do we represent this using the Minterms? So, the Minterms here, if you notice that the output is represented by f. Okay? F as a function of A, B, C, and D. Okay? Now, this is equal to summation of Minterms. What are the Minterms here? We consider, since this is sum of product expression, we consider the output with a value of 1. Okay? So we have here f is 1, and in the decimal equivalent, that is 0 here. No? So you have 0, then you have 1, then you have 4. These are the Minterms. Then you have 5. Then you have 6. Then you have 8, 9, 10. So you have 8, 9, 10, and then 12, 13, and 14. So you have 12, 13, and 14. So these are your Minterms. No? Okay? So again, the Minterms are obtained based on the output here with a value of 1, and then its corresponding decimal places. Okay? So for example, this one here, you have 0, 1, and so on. By the way, how do we obtain the combinational values here? All we have to do is to convert these decimal values into 4-bit binary form. So for example, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 2, since this is 1 here, 2, 4, 8, so you have 2, then 3, 2 plus 1, then 4, you have 4 here, 5, and so on. So that's how we obtain the combinational values of a 4-input variable. So again, go back to our Minterms. That will be our Minterms. Then next is to draw the K-map equivalent. Okay. So you have inputs A, B, C, D. Again, 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. Okay. Now, this cell here belongs to 0, 0, 0, 0. In decimal number, 0, 0, 0, 0 is 0. So you place a 0 at the topmost part of your cell. Okay. This one here, 0, 0, 0, 1 is equivalent to 1 in decimal form. Then, 0, 0, 1, 1 is 3. So this will be 3 here. And then 0, 0, 1, 0 is 2. So you have 2. Then 0, 1, 0, 0, that is what? That is equivalent to 4 in decimal number. Here, oh. If you look at that, 0, 1, 0, 0 is 4. So you put a 4 here. And then 0, 1, 0, 1 0, 1, 0, 1 is 5. So you put the 5 here. And then 0, 1, 1, 1. What is that? 0, 1, 1, 1 is 7. So you have 7 here. And then here is 6. 1, 0, 1, 0. 0, 1, 1, 0 is 6. And then here, you have 1, 0, 0, 0. Where's 1, 0, 0, 0? 1, 0, 0, 0 is 8. So you place it here. 8. Then this one here is 9. Then down, 10. 11. Then go back to the center. 12. 13. Then go down. 14. And then 15. That will be the location of your cells. No? So again, this is 0, 1, the 2 is down, 2, 3, then 4, 5, 6 is down, then 7, then 8 on the last part, 8, 9, then down, 10, 11, then 12, 13, down, 14, 15. That will be the location of your cells. Okay? Then we find the minterms into our, or we place our minterms into our cells. So you have 0, since this is sum of product, we put a 1 here in the 0, then 1, then 4, 5, 6, 8, 9, 10, 12, 13, and 14. So that will be our location of minterms. Again, in the sum of product expression, this is A bar here, and this is A, this is B, B bar, B bar, this one here is C, C bar, then D, D bar, D bar. Okay? The same, we group the cells which are adjacent. Okay? Again, we have 16 cells. Kung wala yung 16 cells because there are vacant cells here, we go to 8 adjacent cells. So in this case, we have 8 adjacent cells. So we group them as 1. Okay? And then, find another 8 cells which are adjacent. In this case, wala na. Then we go to 4 adjacent cells. Where are the 4 adjacent cells? Na? Okay. This one here and this one here are adjacent. So, this will be your grouping. Okay? That is adjacent. Now, what is left is this one. Now, you might be thinking that we have to combine this cell here and this cell here only. In other words, 2 adjacent cells lang. But this time, you have to consider that these 2 cells here are also adjacent to this cell here. Yun sa ito, once you fold it, mas kaningan 2 ka cell, kung kaningan 2 ka cell are adjacent. So since this cell here is not yet grouped, then we use the other cells to maximize the grouping. So again, we have 4 adjacent cells here. Okay? So since all of the cells are grouped na, then we stop the grouping. Then we determine the equation. This one here, that belongs in this particular area, that is D bar, or this is under A. Okay, this one is under A, and at the same time under D bar. So product term. Okay, SOP, sum of product expression. So you have product term. Then this one here, this one and this one, this is under what? B. Okay, this is under B. At the same time under D bar. Okay? And then you have 8 adjacent cells. This belongs to C only. C bar. Okay? So that will be our equation. So the final equation will be C bar plus A D bar plus B D bar is equal to F as a function of A, B, C, and D. Okay? This will be your equation. So if you want to obtain the logical circuit equivalent, so we have two AND gates. This one, A and D, A D bar, B D bar. So you have A D bar, then you have B D bar, B D, and they are being OR to C bar. So OR gate, then C complement. That is your X. That will be, or I mean F as a function of A, B, C, and D. Okay. That will be your simplified logical circuit. Okay, so Maxterm. Maxterm, actually it is just product of some expression. The Maxterm is represented by the symbol pi capital M. Again, we have here a truth table based on a particular problem. Okay, so the output is based on the condition of your problem. So, we have to make again a map. Okay. You have 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Again, we locate the decimal equivalent in our map. So this one here is 0 again. This is 1. Go down. 2, 3. The same is in your SOP. Then you have 4, 5, down, 6, 7. Side, 8, 9, down, 10, 11. Go back to the center, 12, 13, down, 14, 15. So what will be our Maxterm here in this particular table? So you have F as a function of A, B, C, D is equal to pi, capital M. Then you have the Maxterms here. Consider again a value of F, which is 0 this time, because this is product of some expression. You have 0, 0, 0. So you have 0, 1, 4, 5, 0, 1, 4, 5, and then 8 going to 15. So you have 8, 9, 10, 11, 12, 13, 14, and 15. Okay? Then, we locate this Maxterm in your map. Okay? So, this time, we use the value 0. So, 0 and 1 is Maxterm, so you put 0 here, not 1 but 0. 0, 1, then 4, 5, 8, 9, 10, 11, 12, 13, 14, and 15. So that will be our location of the Maxterm. Then again, we group the cells which are adjacent. So you have 16, there's no 16 cells adjacent. So we go to 8 adjacent cells. So in this case, this one here, 8 adjacent cells. So we group them as one group. Okay? Then, we have here 4 remaining cells. Instead of grouping this as 4, since they are also adjacent here, so we make an 8 adjacent cells. Not only 4, but 8. So, ayaw biyahe ang 8. No? Kung napa kayo makita nga 8 adjacent cells, i-group yapon siya. Okay? Ayaw pagkanto sa 4 if there is still 8 adjacent cells. Because if you do that, then your final equation will not be a simplified equation. Okay? So in this case, we know that this one here, in your product of sum expression, baliktad na siya. This is now your A. This part here is your A bar. Diba? Then this is your B bar. B. B. And this one here is your C bar. Here is C. And then this is your D bar, D, and D. So baliktad na siya sa Minterm, no? Which is your SOP. This time, we have the Maxterm. So baliktad ang location sa imuhang variables. So what will be our equation? So this one here, this 8 adjacent cells, this one is under C. Okay? And this one here is under A bar. So this one here is a sum term. And this is another sum term. And since we are using product of sum means what? These are sum terms logically multiplied together. So since A bar is a sum terms and C is another sum term and they are logically multiplied together. So A bar times C is equal to F as a function of A, B, C, and D. So what will be our logical equation? Just simple AND gate. You have A complement times C. So you have F as a function of A, B, C, and D. So this will be your simplified logical circuit.